Alright, what is up? It's your boy the Canologist. We're going to be doing the question. Container with the most water. Okay. This is a medium Leetcode. Given an integer array, height of length n. Okay. There are n vertical lines drawn such that there's two endpoints of the ith line are I and 0. I to 0, okay, of the ith line. So there's n lines, the ith line, endpoints of the line are I and 0. And I and height I. Find the two lines that together the x-axis form a container such that the container contains the most water. Okay, so basically you're saying there's a bunch of lines on this plane, and we want to find out which line will hold the most water. Alright. Okay. That together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. Okay. So let's look at this shit. We have 1 and 7. 1 and 7, so no. 8. Okay. 8 and 8. Okay. So you need some sort of matching height. You get 8, you get 7. The above vertical lines are represented by array 1862548, whatever, 837. In this case, the max area of water, blue section, the container can contain is 49. Why? Oh, because the max height goes up to 7. It looks like. You can go up to 7. So 7. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 times 7. 56. So 8 times 7 is 56, yeah. So 56. Wait, here's the thing with that. It's like, what am I trying to do here? Why is it 49? Why is that 49 is the issue? Because I'm counting 8, the highest is 7, so along with the x-axis, form a container such that the container holds most water. Right, so 1, 2, 3, 4, 5, 6, 7. Oh, okay. I see, because it's distance between. It doesn't count the lines, it counts with what's within the bounds. So this is 1, 2, 3, 4, 5, 6, 7. Right? And then the height would be the lowest of the two. So it would be 7. Because 8, you can't have 8 and 7. You can't use 8 as the height because the 8 water would overflow. So it only holds what's with 7 and below. So you get 7 times 7 is 49. That's what I'm thinking is the case right here. So that's my analysis of the question. The next one would have been, let's say, for example, if this was 6, let's say the 8 was a 2, right? And let's say this is 6 and 7, right? It'd be 1, 2, 3, 4, 5, 6. And then because 7 is taller, this water would overflow, so you'd only have 6 as the max height. So what you do is 6 times 6 is 36. I'm guessing that's what this is. Input height 1 and 1. The output is 1. So it'd be this would be 1 and 1. So yeah, you'd have 1 times 1. 1 space. So n equals height dot length. N equals height dot length, height dot length, height dot length. So n equals height dot length, which is height is all these different heights. So, and then n is between 2 and 10 to the 5. So it's basically saying this has a minimum of 2 elements. So, because if you have 1 element, you can't contain any water. Right? So it has to have at least 2 elements. Second, the height could be 0. Okay, so if a height is 0 and you only have 2 elements, height I of each one could be 0. So let's go to the whiteboard. I want to intuitively see if I can intuitively solve it. And if I can intuitively solve it, so basically just looking at the question and trying to solve it without any code. If I just want to look at it and try and solve it, that would be my first step. So if I was to do this, right, and I mimic it, so we do 1, 2, 3, let's make this taller, 4, 5, let's make this taller than this, 6, 7, 8. So let's make this taller than that line. So these 2 lines are like the target lines, for example. So you have 8, but you'd have 1, 2, 3, 4, 5. So you have 8 times 5 is 40, right? But you also want to get 6. So if you have 8 times 5, so 8 times, you get the highest height, right? So your highest height is, it's your minimum height between 2 points. So let's say we use the 9, right? Because for example, if we look at this, this is the same height, 8 times 8, right? But because you only use one of these heights, you don't use both, it's not 8 times 8, it's just 8. So let's say 9 times 8, you only use 8 here because it's on the left side of the bound. So you have to make sure you have the maximum x as well. You see what I'm saying? So you have to have the maximum x. So if you go 8, let's say this is 8, 8 times 5 is 40, right? Let's say this is 7, right? Let's say this is 7. 7 is is smaller than 8, so you take the minimum height between 2 points, and then what's it called? Then you get, it'll be times 6 now. 7 times 6 equals 42. So you want to find the maximum height between 2 points, and you take the minimum of that, because that's what's going to not overflow, right? Because if you have 8, this water overflows, you level to 7, right? So, but you have a greater 6, you have a greater x-axis. So you want to find the height, the kind of sweet spot of that height that gets you the most So what I'm thinking is I could do this. Looks like a classic two-pointer method, right? Because I have 2 points that I want to measure from. So I could start a pointer at the end of the array and a pointer at the beginning of the array and shrink, because we can't cross over because we can't have a container that goes backwards, right? So we're just going to keep shrinking the container like this. So if we do that, then I can get these 2 points, and whatever it doesn't matter what they equal, and keep going, keep shrinking, and then take the x-axis of every shrinked point along the way. And then I just return whatever's the max area, right? So all it cares about in the output is the max output. So right now my max I'm going to make is 0. So max out equals 0. Second thing, first I'm also going to define my points. So left 0, right equals length of height minus 1. So len of height, this array, minus 1 to get the last index of that array. So for example, left would be 0, this is the 1, and height would be the 7. And then I have a max value, max output. Let's just call it that so we know what it is. The next point is I want to, first I could take, and maybe this is not the most efficient way of solving. But it looks like if there's a larger value to the right, then I want to move there. If there's no larger value to the right, we don't move to the left. We don't keep moving, right? Because why doesn't it just go here? Why doesn't it just go here or here or here? Why did they pick this place to stop? So I'm thinking we start at the left. If the next element is greater, then we go, because we want the maximum height we can. Also, we can also start at the right, and if the maximum height is greater, if moving to the left is greater, then we'll move to the left. Otherwise, we'll stay where we are. Right? And I think it didn't move to this because 1, 2, 3, 4, 5. That would be 8 times 5 is 40. This is 49. Because you lose the x-axis by going 2 spaces. You lose 2 x-axis points, right? Rather than here. And because this is smaller, there's no point in doing that, right? Like for example, if we were to go, if this was to be 9, or this was to be 8, it would be 8 times 6 is 48. Actually, you'd still want to go to the right. So you want the largest, so 8 times, right, this would be 1, 2, 3, 4, 5, 6. 8 times 6 is 48. And then 7 times, what do you got here? 1, 2, 3, 4, 5, 6, 7. Sometimes 7 is 49. Okay, so let's just get all the possibilities by moving the points. You can move the points left or right. Okay, so now I have left and right. So while L They can't equal each other. And then left minus right. So first I want to also get my positions. So it's going to be, let's say this is 1. I want to get the distance between these two. So let's say this is going to be 1, 2, 3, 4, 5. So 1 and 1 would be 1. 1 and 2. So whatever this is, it would be left index minus the right index, or right index minus the left index, plus 1. Because the array is 0 index, you have to add 1. So while L is less than R, so while L is less than R, I want to go yeah, so while L is less than R, I want to go height at L. So output height at L, so it'd be height at R minus height at L, and then plus 1 for distance, and then I want to multiply that, so the distance times the greater height. So it'd be times times the max of height R height L. So the max element here times this distance is going to be the output. And then I'm going to say max output equals the maximum value of itself, max output, and output, and current output. Let's put current output. So now that I have that, at every iteration of this while loop, I'm constantly pinging what the length is times the max height between my two bounds, my two red bounds. So, oh no, it's min height. I want the max value, which is the output, but the min height. You see what I'm saying? Because if you have 8 and 7, the 8 overflows. You only get what matches. So 7 is going to be the pick. That's why you're going 1, 2, 3, 4, 5, 6, 7 times 7. Because this is this portion of the water overflows. If you have 8 and 7, because there's more water. If you have 8 and 8, it stays, right? But you get the min height between these 2 points. But you want to see if the output is greater than the current output. You know what I'm saying? So we have this. Then I want to check my criteria for moving to the left. I want the greatest possible height on both sides. So if I could do 3 while loops and just do it like this. I could just copy all the logic. So I could do one where all the shit goes to the left, right? And then we test at each point. Do one where all the stuff goes to the right, that we test at each point. And then I could do all the stuff where it goes to the middle and test at each point. That should cover all the possibilities, unless I'm missing something, unless there's some sort of criteria to move these. Because right now it's at the end. So I could say if, I'm just looking at what this would be, if L minus 1 if L is left, so if right minus 1, height at right minus 1, right minus 1, so this element here, if it is smaller, yeah, so if this element is greater than, strictly greater than, because if it's the same size, then you just get less of an X element. So if height R minus 1 is greater than, no, it's less than, strictly less than, height at right now, height at the current right element, and this height is currently smaller and this height on the right side is currently smaller, then don't move it. On the right is currently smaller than the left bound. Less than or equal to height at left So basically whatever this is, I don't want to move it. So if this is greater than, so the height right minus 1 is less than, then I don't want to move it. So that means if it's greater than, I do want to move it. If the height right is less than or equal to, if the height on the right side is less than or equal to, so then also if this is greater than, oh wait, then I don't want to move it. Then I do want to move it. So right minus 1 is this. So this is greater. Okay, so this is like a little bit of a Tracy issue. I have to like trace what I'm doing. So height right minus 1 is this. This value is greater than the current value, and yes, I do want to move it. But it also has to be greater than this value for it to be worth it. Strictly greater. That way I get more water. In worst case, I can do the triple loop method after if this doesn't work out. Then I want to go what's called left minus equals 1. Elif, because I only want to do one at a time. As to keep the x-axis as great as possible. I don't want to ever shrink twice, because then I lose 2 values of x. So elif, and I have to do the logic for the right side. And it's going to keep doing that until it breaks out. That way we get the max. Like the whole intention of this logic here is to keep the maximum x distance as possible without having to increase the amount of times we have to loop over this thing. So save time. So if item on the left, so item on the right has to be thing. So item on the left. So height. Left plus 1 is greater than height at left. Then I also, this one's right minus 1 because I want to move this way. This is left plus 1 so I want to move this way. So if this left is greater than, and height at left oh, this would be right minus 1 because the one moving to the left would be greater than this to keep the, because I want to move to the right. Oh, this would be right minus 1. This would be height at left plus 1 is greater than height at right. So that way if this is bigger, then I get more here. So I either move left towards the end or right towards the beginning. And then else breakout. So we don't infinite. Actually, it's going to keep doing its thing anyways. Else break. That way I just get the max of whatever I do. With the new L and R. Oh, left and right. It's not L and R, it's left and right. Right, left, right, left. Should be good. And then I just return max output at the end once it's done. Return max output. Because every loop it's going to check these conditions. So you get the current output compared to the max and take the greatest value. So I'll only ever get the greatest value or the greater value from 0. It can never be less than, even if it's the wrong logic. Okay, so output 749, so let's case 2. 1 and 1 is 1. Okay, cool. Okay, so why do I get 7? So it's giving me 7 instead of 49. Let me run it. I just want to see the test case and why it's failing. Okay, so I'm getting 7, expected 49. Current output 7 times the minimum height between the height left and height right. Alright, so that would be the minimum of these two times the distance. So right minus left plus 1. So example, this is 1, 2, and 2 minus 1. So this would be 0, 1, is 1 plus 1 is 2. So So where does it get 7? How do you get a 7? Height rates. So this value because I'm doing indexes. So it's actually just going to be right and left. Right and left, not values. That should fix things. Let's try that. 56. Okay. So something's off by 1 now. 8 times 7 is 56. 7 times 7 is 49. So let me just get rid of the plus 1. Let's try that. That should pass. There we go. It was just the indexing. It's just left and right. Because you're minusing left and right from each other. But there's 0 indexed anyways, so you get the distance. So let's say this is 0 and 1. So 1 minus 0 is 1. So you 2, 0, 1, 2. 2 minus 0 is going to be 2. So I'm right. So basically it has to meet this condition every time it checks the minimum height and it checks the distance between right and left. What? Runtime error. Oh, higged. I put higged. Where is that? Where's the error? Here. Height. Run. Pass the test case. Wrong answer. I put 3, 4. 1, 2, 3, 4. Oh, why does it do that? How much time do I have, by the way? Oh, we're at 34 minutes. Okay, let's just see what's wrong with the code and correct. Because we don't want to spend too long on it. Let's just figure out what's wrong with it and then move on to the next question. Because I'm trying to get good. I'm not trying to waste time. If you want to struggle through questions and just never fucking get things done, that's one viable strategy. Right. But for me, I'm trying to maximize output. Oh, it doesn't take into account the zeros too, so it's fine. If the height is 0, then that would be an edge case only for one of them. But let's try it here. Instructions. My code fix my code. Let's see how far I got. Your code has a good structure. There's a few logical issues need to be addressed. To calculate. Okay, so the main problem is the condition used to move the left and right pointers. Okay, so that's fine. Which may lead to incorrect results or an infinite loop. Okay. Move the pointer pointing to the shorter line. Okay, so all this stuff is correct so far. All it does now is okay, so it's just a simple 2-pointer. I just overcomplicated it. Height left. If the height at left is less than the height at right, move it +1, else move -. Okay, fine. It was basically exactly what I thought in the beginning. I just overthought it because of these fucking lines and shit here. So all I have to do is this. All the checks remain the same. So right now they do a while loop here, and then I just put my if condition in here. So if left is less than right, so we don't cross. And then this is just a simple. So I kind of overthought it, but I had the general concept correct in the beginning. I just kind of overthought it, and that threw me off. So all I have to do is this: left and right if height left is less than height and then what do they do here? Yeah, so else right -1. There we go. That's it. That's really all there is. So it's basically just saying left and right. We just keep shrinking. We have to find a way to shrink and end this while loop to figure out all the possible combinations, keeping the width at maximum. Then the next thing is if the left is less than the right, shift. If the right, else just shift the right by 1. Right, and then keep shifting the right until one of them ends up crossing. So one of them is definitely going to end up crossing. And then you end up just getting your max output. It's a lot simpler. Let's try it. It works. Let's try it again. There you go. Beats 5.0% of other solutions. A lot simpler than we thought it was. So original assumptions, this stuff happens all the time, right? Like, it's not a big deal. All you have to do is just reevaluate your position, right? I'm never going to be married to a result, right? Like, if something isn't right, I'm going to check it, correct it, come back to it, right? And that way, the next problem, I'll be a lot stronger, right? Just like we did in the easies. So if you like this problem, please give it a thumbs up, subscribe, comment below. Okay, and I'll just out.